In this lesson, we're going to talk about models and uncertainty. Now, by models, I don't mean physical models, I mean mental or mathematical models. Now, this topic is arguably one place where physicists are most useful in real-world situations. When we talk to people in government and industry and ask, what do you want for our physics graduates, they often say, we want people who can think like a physicist. And what does that mean? It's usually a combination of two things. One is going to first principles, so always trying to find the underlying causes for things and the fundamental reasons. And the other thing is the ability to come up with models. So ChatGPT told me that a model is a simplified representation of a system, concept or process designed to explain, predict or analyze behaviors or outcomes. This is, of course, what physicists do all the time. Let's say you've got a physics problem. You're firing a projectile or you're trying to work out heat flow or something like this. In every situation, you will simplify the situation down. Like for projectile motion, you might ignore wind resistance, you might ignore Coriolis force or the variation in gravity with altitude because they're not important for what you try to work out. And then you can calculate where your projectile will go. So it's always a case of take your situation, try and work out what's important and what's not important and simplify it down by only focusing on the things that really make a difference. And then once you focused it down on that, you can understand what's going on and actually use mathematics to predict the future. So it's a way to understand complicated things in a simple way by making approximations and building a model. So why should anyone in the real world care about this? Well, models are crucial. One reason is decision making. Let's say you're a government and you've got to decide, do you declare war with a neighbouring country, or do you raise interest rates, or do you pass a new tax law, or anything like this. You want to know what's going to happen. If I declare war on this country, will I win? Will I lose? If I raise interest rates, will I lose the next election? Will I get more tax revenue? And so on. So you're always doing hypotheticals. If I did this, what will happen? And models what will tell you that. Not necessarily 100%, but they're your best tool to work out the consequences of possible actions. The other related reason is risk identification. Models might tell you, if we keep putting out CO2, the temperature will get really high and we'll all die. Or there's a risk of a giant solar storm or a volcano or something like that. So models can help us identify things that could go wrong before they go wrong, but it's relatively easy to do something about it, prepare or avert the catastrophe, as opposed to just waiting for something to go wrong and then trying to fix it afterwards. Now, there's a very famous quote, all models are wrong, but some are useful, quoted from the statistician George Box. A model is a simplified version of the world. It has to be. The real world is so complicated you can't get all the details in. Sometimes you can get pretty close. Sometimes you'll be a way out, depending whether you're doing astrophysics or, sociology. But you're always making assumptions, deciding this is important and this is not important. And that means they're always going to be wrong. But if you've made the right assumptions, it can tell you something and it can get the answer pretty close to right. Whereas if you make a stupid assumption, for example, if you're throwing a bowling ball through the air, it's a good assumption that you can ignore wind resistance, but it's not a good assumption that you can ignore gravity. If you're firing a projectile hundreds of kilometers, like an artillery shell or something like that, then ignoring Coriolis force is a very bad approximation. So knowing what approximations to make, what's important and what's not, and you test your models against historical data. So something like a climate model, you'd say, does it explain the climate in the past? An economic model, did it explain the Great Depression? So you're always testing these models against historical data or by making predictions. The best way to test the model is to say, I think this is going to happen tomorrow, and then tomorrow go and see if it did. If it didn't, maybe you need to improve your model. Now, all decisions are based on models. People don't often realize this. A lot of models are what we call implicit. That there's a model, but no one's ever written it down or thought it through very carefully. So this often goes by the name of intuition or gut feeling or something like that. But these are still models. So for example, every semester I have to decide how big a room to book for this class. And normally I say, well, we had so many students last semester, therefore book a room big enough for that, maybe with a bit of extra. And that's a model. You might not think it's a model, but the model is next year will be the same as this year. Now, the important thing about defining models is it actually forces you to think through your assumptions. If you're just going by gut feeling, oh, I think that'll happen. I mean, you might be right, you might be wrong, but if you actually have to think, okay, what's my model here? Is my model here that tomorrow will be the same as today? Or how realistic is that? So thinking through what your model is a very good mental discipline to try and work out how good are the assumptions, because heaven knows people get these things wrong a lot of the time.